Hello and welcome to part 8 of this series about object-oriented programming. In this hands-on video, I'll demonstrate in the IDE two types of initialization blocks, instance and class, which I've introduced in the introduction video. I'll show how the instance initialization block can be used to solve an issue we still have with the previous version. So what is a problem in that version? Our client wished to create a new rectangle, but then by passing just 3 arguments. The first two represent x and y, and then the last one, the size, meaning that size will be used for both height and width. In other words, he wanted to create a square. The 3-parameter constructor didn't exist, so it needed to be added. Let's have a look at that constructor in the rectangle class. Suppose that the task of implementing that constructor was given to a new member in the team of developers not very familiar with Java, let alone chaining constructor. And he decides to call the setters separately. Set x, set y, set height, and set width. Then running the code, we didn't have the correct output. Looking at the last 2 lines, we see that 4 rectangles are created, which is not correct because we created 5 rectangles from 1 to 5. What is the problem in the implementation of the 3-parameters constructor? It is that the count isn't incremented. So what this new member of the team should have done was or increment the count here, or invoke the constructor with most parameters, in other words, chain constructors. Either implementation would have solved the problem, but looking at the first option, namely incrementing the count in this constructor, yields redundant code compared to the constructor with most arguments. So the best thing to do would be to chain constructors. But wouldn't it be better altogether to come up with an implementation where a constructor doesn't have to deal at all anymore with taking care of incrementing the count? Let's not put that burden on the constructors. Well, that solution exists, and that solution is called initialization blocks. So let's have a look at how that works. Now, before continuing, I'll remove the count here because I want to keep the same version as before. Version 7 used this implementation for the 3-parameters constructor. I'll create the necessary packages for version 8 and implement a different approach to the problem using initialization blocks. So let me first add the necessary packages. So in lib, right click, new package, demo 8 initialization blocks. Do the same in app and copy the rectangle from version 7 in version 8 and the client from version 7 to version 8. Version 8 of rectangle. Check whether everything's okay. And so we have the same output as in version 7. But let's deal with this 4 rectangles created. It should be 5. So let's implement an initialization block. In the rectangle class, a new comment section. And since initialization blocks are kind of related to constructors, I put a comment block before the comment block of the constructors. So initialization blocks. And there are 2 types, and I start with the instance one. So an instance initialization block. What does it look like? It's like a code block, but without a name. What I'll do here is just increment the counts. Then in the constructors, remove the incrementation of the count in the constructor, and let's run the code. And we have 5 rectangles created. But what happens? Initialization block is invoked before the actual execution of our constructor, and it is invoked automatically when an object is created. Let's debug this code. I put 1 breakpoint at the first instantiation of a rectangle object, the one to which we pass 4 arguments to the constructor. So debug the constructor with 4 parameters will be invoked. But before executing the statements that are inside the code block of the constructor, the runtime invokes and executes the instance initialization block. So the count is incremented from 0 to 1. After the execution of the instance initialization block, control resumes in the constructor that was initially invoked, in which case in this example the 4 setters will be invoked. Set x, set y, set height and set width. Let's see what happens with the default constructor. So the runtime jumps to the default constructor, executes it, but here we have a chain constructor, so that one is invoked but not yet executed as before. First the count is incremented, after which control resumes in the constructor. The same happens in the other 2 constructors, the constructor with 2 parameters and the copy constructor, but we're interested in the constructor with 3 parameters to which we pass 3 arguments. What happens? So the constructor is invoked but not yet executed. First count is incremented, after which the setters are called for this 3 parameters constructor, setting x, y and height and width to the same size. So the thing to remember is that an instance initialization block is executed before the execution of a constructor if that constructor is not invoking another constructor. So as we saw with the default constructor, the invocation of the other constructor is executed first. Once the runtime invokes that constructor, then the initialization block is invoked, incrementing the count, after which control resumes in the constructor. And that solves our problem with the counter. But let's just have the constructor with 3 parameters invoke the constructor with most parameters. So let's use chaining here as well. This x, y, size, size, and remove the other lines. Check whether everything still works. Not debug but run. And we have 5 rectangles created. Problem solved. This for the first part of initialization blocks, namely the instance one, which resolves the problem we have with the counter. Now there is a second type of initialization block that we can use, namely the static one. Go to the rectangle class and define a class related initialization block. It's very similar to an instance initialization block. The only difference is that it is preceded by the static keyword. What is it used for typically? Initializing class members. Let's have a look at the class members that we currently have. And I'm not referring to the count, but particularly the class members that are used during the validation when creating a rectangle. Here they are initialized in the class member variables section. But what you can do is, if I take the example of the min height, so I copy min height and initialize it in a static block. Min height. I get a compiler error saying cannot assign a value to final variable min height. It is because min height is already initialized, namely in the class member variables section. What I have to do is remove the initialization here, after which the compiler error disappears. And we don't have a compiler error anymore. If I were to run the code, I would get exactly the same output. So in this scenario, there is not really a big advantage in initializing my member this way, just by assigning a constant in the static initialization block. It becomes very interesting though if specifications change. Suppose that after our application has been in service for a while, customers decide to change the specification and then they say, oh well, the minimum height must be 5 and not 10. That means that code will have to be changed. So we change the value from 10 to 5. We need to recompile the code, reinstall the software, and problem solved. But then suppose that Shortly after, customers actually decide that the value should be 15. Okay, again, the team of developers need to change this value to 15, recompile the code, reinstall the software, which is quite a cumbersome task, just for changing the value of one specification. And here comes the big advantage of static code blocks. Namely, as you can see, a static code block is, as the name implies, a code block, meaning that I can add code inside my block. And more interesting would it be to get this value not hard-coded in my source code, but for example from a database or an XML configuration file. So what we can do instead is initialize the variable not at compile time, but at runtime. I'll jump ahead a little bit in the demo, and when I come back, I'll show you an example of an implementation that illustrates how the variable can be initialized at runtime. And do that for the other static variables as well. So the minima and maxima for x, y, height and width. Okay, so I'm back. Now, before demonstrating the initialization in the static initialization block of class member variables at runtime, I'm going to show you the compile time initialization of all final class member variables. The first thing I did is remove all the initializations in the class member variables section. So the variables don't get their initial value here. Instead, they get it in the static initialization block over here. And you can say that they are initialized statically, not because there is a static keyword and that it is being executed in the static initialization block. In this context, initialize statically means not at runtime, but at compile time. So this doesn't change anything in the behavior of our program. If I run the code, I get exactly the same behavior and output. It becomes more interesting if I initialize the variables at runtime, so that our code becomes independent of specification changes. I'll pause the recording here for a while, and when I come back, I'll show you an implementation of a dynamic initialization or initialization at runtime. Okay, so I'm back. I start with a compiler error here because what I did is, instead of initializing statically, I want to initialize dynamically. And I show you the details in a second. But why the compiler error? Let's examine this with the first static variable -x. As -x has been initialized once already, you may not assign it a second time. Variable min_x might already have been assigned to. Okay. And so in order to remove the compiler error, and that's what I want to demonstrate, initialize the variables dynamically. So I'll comment the first section and explain you in a nutshell what this is about. Now this is basic code. Is just to demonstrate the idea behind runtime initialization of class variables in a static initialization block. So first of all, for all the minima and maxima, I define a class. And for simplicity's sake, I put everything in the same package demo8 initialization blocks. And I call the class limits. So what I define here is some instance data members, one data member for each specification, min, max, x, for y, for height, and for width, and define some getters and setters for each property. That's basically what this class is all about. Back to the rectangle class. What I do then is I load the limits. It's going to load in the database. I have a small MySQL server running, and in the database that I use, there is a small table limits, and I have defined one field per minima and maxima. So there's a mapping between limits in my table structure. And load limits is going to load the data from the database using GDBC. Let's have a look at that method. And again, these are some basic instructions just to show you the idea. This code can be optimized. I don't want to make it too complicated. It's a private method because nobody else should be able to use this method. It returns a reference to a limits object, which I create in the beginning, and then define some GDBC code. Basically what it does, it initializes my hosts So where I define what my user password and URL are, and then using some JDBC. Create a connection. Using that connection, I obtain a statement, and using the statement object, I execute the query using my SQL commands. Select star from limits. What it returns is a result set, so all the values from the table are loaded in my result set. I step forward to the first record, and then I get every single value by executing this getInt method on the record set, mentioning the name of the column. And then using my setter in the limits class, I set my initial values, and that's basically it. After which, once I'm done, I return the limits back to the invoker, which was the rectangle class. So back to the load limits invocation, because what I'm going to do then is, using the getter this time from my limits object, I initialize each class member. So there's no initialization at compile time anymore, everything happens at runtime. Okay, let me debug this application, and before doing so I'm going to add a few breakpoints. At the first statement in the main, in the static initialization block, just before executing the load limits, the statement after that one, and in the getCount methods. And launch the code in debug. And the first thing I want to demonstrate is an answer to the question you might ask, when is this static initialization block invoked? Well, I can already give you the answer. It is before the invocation of the getCount methods. So let me just do a step over, and it's going to hold at the next breakpoint. And that is in the static initialization block, not in the getCount methods. The load limits loads the data from the database and is going to print out the values in the console, just for demonstration purposes. I'm not going to do a step into, but a step over. And what we see here is the outputs generated in the load limits methods. So these are the values coming from the database for minus and maximum x, for y, for height, and for width. They are all loaded in the limits object, and for each minimum and maximum am I going to assign the loaded value to our class member. Once all the initializations are done, will the getCount method be executed. So let me put a breakpoint here, resume the code, and the next statement is the getCount methods. Returning the count to the clients and printing it out. So two things to remember from the static initialization block. First of all, that it is invoked before any other static methods or instance methods. So from the moment something of the rectangle class is used for the first time. And second, that it can be used to initialize class members at runtime. Okay, so far for the implementation of initialization blocks, and this time no problem to tackle. Rather, let's extend our library of shapes. So far we've only implemented rectangle. But remember the initial customer specifications. Basically what the program needs to do is to be able to draw rectangles and circles. We haven't implemented circle yet. Let's do that in the next version, version 9, and it will be a kind of an introduction to module 2, in which I'll talk about another very important concept in object-oriented programming, namely that of inheritance and polymorphism and related issues. Thank you for watching, and if you like this video, thanks for pressing the like button and or subscribing to my channel. Bye bye.